Hello friends, welcome to Learner's Planet. Friends, this is our second session for basic problems on triangles and other polygons. In the previous session, we discussed the very basic problems from lines and triangles, lines, angles and triangles. In this session, we'll be continuing with more problems. We'll be continuing with similar triangle concept and we'll be touching other concepts as well. And once again, you are suggested to have a copy and pen with you, notebook and pen with you. Just note down the important points and try to do the problems on your own before you see the explanation. Okay, so let's begin. Now the first question, in triangle ABC and DEF, it is given that this. Okay, first of all, what I do is I just draw the two triangles. This is ABC and this is DEF. Okay, ABC, DEF. AB is equal to 5, BC is equal to 4, CA is equal to 4.2, DE is equal to 10, FE is equal to 8 and FD is equal to 8.4. If AL is perpendicular to BC, AL is perpendicular to BC and DM is perpendicular to EF. Okay, then find AL is to DM. Now that's pretty simple. ABC and DEF, you can observe that the three sides are in proportion. It is 5, it is 10, double of that, 4.2, 8.4 double, 4 and 8 double. That means triangle ABC and DEF, they are similar to each other, right? If the triangles are similar to each other, their altitudes will also be in the same proportion, right? So AL and DM, they will also be in the ratio 1:2. Okay, so altitudes will also be in the same proportion, medians will also be in the same proportion, and angle bisectors will be also in the same proportion. So if you know the triangles, if you can see the triangles are similar, then you can crack this problem very easily, even you don't have to draw the diagram. But if you don't know the triangles are similar, then you cannot in fact solve this problem. Okay, now triangle ABC and DEF are similar. The question is, area of triangle ABC is equal to 16 and area DEF is 25 centimeter square. Okay, now when the two triangles are similar, ratio of their area, suppose it is area of triangle ABC by area of triangle DEF, that is square of, or I can say BC square, because I know BC is the side, by EF square, right? Generally when in exams the two triangles are given as similar, then you can take the sides as AB is in proportion to DE, BC in proportion to DF and AC in proportion to DF. Okay, so here BC in proportion to EF. So BC square by EF square. So area of triangle ABC is what? 16. Area of triangle DEF is what? 25. So BC by EF will be square root of them, 4 by 5. Now you know BC, so that is 2.3. So EF can be calculated easily. That is 5 into 2.3 by 4. Right? Pretty simple. Similarly, if AC and DF given, find the ratio of the areas of two triangle. Now AC and DF, right? That means the same sides are in proportion. So area of the triangle will be 19, area ratio will be 19 square by 8 square. Okay, so generally in exams, when the two triangles are given as similar, the sides can be taken, sides in fact should be taken in the same order as I am telling you. AB by DE, BC by EF, AC by DF. Okay, similarly you can do this third problem also. Now two isosceles triangles have equal vertical angles and their areas are in ratio this is, find the ratio of their corresponding heights. Now see, in case of isosceles triangle, just draw a rough diagram. This is a triangle isosceles triangle, and this is, just a moment, this is also an isosceles triangle. Now in case of isosceles triangle, these two angles are same, right? But over here it is given that this vertex angles are also same. That means the three angles of this triangle and the three angles of this triangle same. That means these two triangles are similar, right? Now if the triangles are similar, the ratio of their sides will be square root of ratio of their areas. So ratio is area ratio is 36:25. That means side ratio will be 6:5. Okay, side ratio will be 6:5 and height ratio will also be 6:5. Pretty simple. Now if ABC, in triangle ABC, P divides the side AB such that AP by PB is this, Q is a point on AC such that PQ is parallel to BC, find the ratio of areas of triangle APQ and trapezium BPQC. So first of all I just draw the triangle over here. This is the triangle ABC, AP by PB. So what I do is I draw a line PQ that is parallel to BC. Okay, so this is the triangle ABC. This is PQ. Now AP is to PB is 1:2. Okay, now we have to find out the ratio of areas of triangle APQ and trapezium BPQC. Okay, so the problem bit twisted, not at all difficult. Now triangle, since PQ is parallel to BC, now I don't have to remind you that in that case APQ will be similar to ABC. Triangle APQ will be similar to triangle ABC, right? That means area of triangle APQ by area of triangle ABC will be equal to square of their corresponding sides. So here it is 1 square, and in triangle ABC this complete length is 9. So I'm sorry, 3, so square will be 9. So area ratio is 1 by 9 of APQ and ABC. That means we can say area of triangle ABC by area of triangle APQ will be 9. Now area of ABC can be written as area of APQ plus trapezium BPQC, because ABC is a combination of APQ and BPQC, by area of APQ is equal to 9, right? So if you break it, it will be getting 1 plus BPQC by triangle APQ, that equals to 9. So this is equals to 8. Okay, so we have to find out ratio of areas of APQ and BPQC. So APQ and BPQC will be 1:8. Okay, so precisely what is happening, instead of doing so much of paperwork in your exam, if you know this is 1, right, this complete is 9, right? So this is 1, this complete is 9, that means it must be 8. As simple as that. But for the concept clarity, I have done this much work. So once you are clear how the problem is done, after that you'll be very confidently marking the answer, very confidently you'll be doing this procedure. That would take only seconds of yours, right? This length is 1, this entire length will be 3. So if the two triangles are similar, then their areas will be in the ratio of square of their sides. So the ratio of area will be 1:9. Now this is 1, that means this is 8. As simple as that. Okay. The areas of two similar triangles are this and this. If median of first triangle is this, then the corresponding median of the other. Okay, once again very simple. The area of similar triangle in the ratio 121 and 64, that means median ratio will be square root of this by square root of this. Okay, 11 by 8, and that is actually 12.1 by m2, right? That's already given. If the median of the first triangle is 12.1, find the corresponding median of other. Now if it is 11, it is 12.1. So if it is 8, if I remove this decimal, so I'll be getting 10 over here. So it is 11, this is 12.1. Then if it is 8, it has to be 64. That means precisely it is 12.1, then it has to be 6.4. Okay? Pretty simple. So when the two triangles are similar to each other, their area ratio of their area is equal to square of their corresponding medians, ratio of corresponding medians. Okay. Now in triangle ABC, PQ is a line segment intersecting AB at P and AC at Q such that PQ is parallel to BC. Okay, I just draw the triangle. So triangle, then we have line PQ that is parallel to BC. Okay, now what does it say? It's A, B, C, P, Q. Okay, now PQ is parallel to BC. PQ divides ABC into two equal parts. Okay, PQ divides triangle ABC into two equal parts. That means area of this region and area of this region is equal, right? Equal in areas. So we have to find out BP is to AB. Okay, so that's pretty interesting problem, very frequently asked in competitive exams. Now I assume the area of triangle APQ is x square, then area of BPQC will also be x square. That means the area of triangle ABC will be 2x square, right? Now triangle APQ is similar to triangle ABC, so their area ratio, that is 2x square by x square, will be equal to AP square. I'm sorry, this is 2x square, so that is AB square by AP square, right? So AB square by AP square is 2x square by x square. That is the ratio of areas of their these triangles is equal to square of their corresponding sides. So AB square by AP square. That means AB by AP is equal to root 2 by 1. Now we have to find out BP by AB. So AB is equal to root 2k. So this is ratio, so we cannot take it directly as root 2. So AB is equal to root 2k and AP is equal to k. That means BP is equal to root 2k minus k. Okay, so BP is root 2k minus k by AB is root 2k. So that is root 2 minus 1 by root 2. So that is the ratio of BP and AB. I hope you are clear. Very important problem. Now this problem, a very simple one. A ladder 17 meter long reaches a window of a building 15 meter above the ground. Find the distance of the foot of ladder from the building. Okay, now ladder must be slanting, obviously. So what you'll be getting a right angle triangle over here. Just draw. So this is ladder, this is wall, this is the distance between ladder and foot of the wall, right? So obviously this is a right angle triangle will be getting over here. This is 17, this is 15, and we know 8, 15, 17 Pythagorean triplets. So this must be 8, 17, 15 and 8. So a very basic problem from Pythagoras theorem. Determine the length of AD in terms of B and C. Here B and C, legs of this right angle triangle. This is right angle triangle. BC altitude and AD is also altitude. That's given actually. Now we have to find out the length AD in terms of B and C. So what is the first step? First of all, we need to find out the length BC. That is root of B square plus C square. Now we have to find out length AD. Okay, now that's an important concept I am going to discuss over here. Very frequently this concept we have to use. Now then, in this case, what is the area of triangle? That is half base into perpendicular. So half B into C. In other words, what is the area of this triangle if this is the base? So it is half base into altitude. So base is B square plus C square and altitude is AD. Now in this expression only AD is unknown, so that can be calculated very easily. So suppose in exams you are given the value of B and C, then you can put up the value over here, or directly suppose it is 3 and it is 4, then it must be 5. So half of 3 into 4 is equal to 5 into AD. So this is 6, so AD is equal to 6 by 5. Can be calculated very easily. So what we have done over here, what concept we have applied? Area of the triangle is half base into altitude. In other words, this is the base and this is the altitude. Okay. Since the area of the triangle will remain same in both the cases, the unknown quantity AD can be calculated easily. Right? ABCD is a square, F is the midpoint of AB and BE is 1/3 of BC. If the area of FBE is 108, find the length AC. Okay, first of all we draw the diagram. ABCD is a square. A, B, C, D. Then B is F is the midpoint, so this is F is the midpoint of AB. BE is 1/3 of BC. BE is somewhere here, and BE is 1/3 of BC. So this ratio is 1:2. That means BE is to EC 1:2, right? Because BE is 1/3 of total length BC. So if it is one part, it has to be two part. Then only BE will be 1/3 of BC, isn't it? 1 and 1 plus 2. Okay. Now if the area of FBE, so I join these 2 points. Now FBE area is 108. We have to find the length AC. Length AC, that means precisely diagonal of this triangle. Okay. Now see this AB, I suppose AB to be maybe, see here it is multiple of 3 and here it is multiple of 2. So it would be easy for us if we take a common multiple of 2 and 3, that is 6, right? So I suppose AB is 6x. Then FB will be 3x and this will be 1/3 of 6x, that is 2x. Okay, because AB will be equal to BC. Both of them are sides of square. Right, so this is 1/3 of BC and this BF is half of AB and AB is equal to BC. So this is 2x and this is 3x. So we have been given the area of triangle FBE. FBE, that is 108. So half of 3x into 2x is equal to 108. Okay, so 336. So x square is 36, that means x is equal to 6. Now AB we assume to be 6x, x is equal to 6, that means AB is equal to 36. Now AB is 36, BC is 36, so AC square is equal to AB square plus BC square. So it is AB is 36 square and this is 36 square, so it will be 36√2. Okay, I hope you are clear. Now in this problem, in the figure, AM is equal to MB is equal to MC is equal to 5 and BC is equal to 6, the area of triangle ABC. Okay, so area of triangle ABC. since in this triangle AMC this is 5, that means this angle must be equal to this angle, and in this triangle this is 5, that means these two angles must be same. Okay, it is not necessary that this angle is equal to this angle. Be careful about it. You have to assume both the angles to be different. Now x plus y plus y, sum of the four angles must be 180 degree because it is a triangle. So x plus y plus y. So precisely 2x plus 2y is 180. That means x plus y is equal to 90. X plus y is equal to 90. That means it is a right angle triangle, right? If it is a right angle triangle, this is 6, this is 10, the total length 5 plus 5 10, that means it must be 8. Okay, so area of triangle ABC is half base into altitude. Base is 6, altitude is 8, and half of 8 into 6 is 24. Pretty simple. Okay, an equilateral triangle and a square have equal perimeters. Find the area, ratio of area of triangle and area of square. Okay, now this sort of problems are frequently asked in competitive exams. If you know the relation directly, you can mark the answer, and if you don't know, then you can derive it. That's very simple. Now since the perimeters is same, perimeters are same of both the figures, what we can do is we can take the perimeter as any multiple of 3 and 4 both, right? So if we do 1/3 and if we do 1/4, we should not get the fractional value. So the simple simple number comes in my mind is 12, right? So perimeter of both the figures is 12. So side of equilateral triangle is 3 and side of square is 3, right? Now side of equilateral triangle is 3. Area of equilateral triangle is what? Root 3 by 4 side square. Root 3 by 4 side square. So side is 12 divided by 3, it's 4. Okay, so root 3 by 4 side square divided by area of square. Area, the perimeter is 12, so side will be 3, so area will be 9. Okay, so it is 4 root 3 by 9. 4 root 3 by 9. So if at all you don't know the relationship directly, then you can derive it in this manner. So sometimes you are given the combination of triangle and square, sometimes you are given the combination of triangle, square and circle, maybe square and circle. So in the same way you should proceed. It will not take more than 30 seconds of yours, and the problems, this sort of problems are really very easy to do. In the figure, ABCDE and ABXYZ are two identical regular pentagons of fine angle AEZ. AEZ. Okay, pretty interesting question. If it is a regular pentagon, each angle should be 108 degree, right? That we have already discussed in our basic session. Total value, sum of all the angles will be n minus 2 into 180. That is n is equal to 5 over here, so that's 540 divided by 5. So each angle will be of 108 degree. So this is 108, this is 108, right? And the total angle over here should be 360 degree. So 360 minus 108 2 times 216, that will be the value of angle A. Okay, so angle A is 144. Now in triangle AEZ, angle A is 144 and AZ is equal to AE because they are identical regular hexagon. So AE is equal to AZ. That means this angle will be equal to this angle. So out of 180, if we deduct 144, we are left with 36 degree. So angle E plus angle Z is 36. That means half of them will be given to each. So this is 18 degree, right? I hope you are clear. In the figure, the rectangle has perimeter this and area this. Find the length of its diagonal AC. Okay, perimeter is 16. That means and the length of AB is X and BC is Y. That is half of the perimeter. So X plus Y must be half of 16, that is 8. And area is 15. That means X into Y is equal to 15. Now x plus y is 8, xy is 15. So pretty simple. You can assume two numbers. Sum should be 8, product should be 15. So it is 5 and 3. Right? So one side is 5 and other side is 3. So if at all we have to find out diagonal AC, then AC square will be 5 square plus 3 square. So 25 plus 9, it is 34. So AC will be root 34. Pretty simple. In the figure, ABCD is a square and ABE is an equilateral triangle. Find the area of AB, ratio of their areas. Okay, that's pretty simple. I assume the side of this square to be same, maybe x, right? So area of triangle ABE, since it is an equilateral triangle having side as AB, then AB, BE, AE, all of them will be equal, being an equilateral triangle. So area will be root 3 by 4 side square, that is x square, and the area of ABCD square will be what? Side square, that's x square. So what is the ratio? Root 3 is to 4. Pretty simple, a 20-30 second question. Now here an interesting challenging problem with us. In the figure, ABCD and EFGH are two squares and ACH is an equilateral triangle. Find AB is to EF. Now see, A, B, C, D and EFGH, both of them are square. So what I do is I assume the side of the smaller square to be A. So this is A, this is A, that means the length of the diagonal will be root 2A, okay, of the square. Now this AC is nothing but the side of this equilateral triangle, as AHC it is given to be an equilateral triangle. So this is root 2A. So side of this equilateral triangle is root 2A. So area of this I assume this point to be P. Area of this equilateral triangle to be root 3 by 4 into side square. So it is 2A square, or I can say root 3 by 2 A square. That is the area of this equilateral triangle. Now from this we can calculate the length of altitude, that is OH. Okay, diagonals of the square, they intersect each other, bisect each other at 90 degree. So we can calculate the length OH. Now how do we calculate this? Base, this is the base of equilateral triangle and the length of this base is root 2A. That is the side of equilateral triangle. So half into base into altitude, that is OH, and that is nothing but the area of this equilateral triangle. So area of triangle can be found in two ways: half base into altitude or root 3 by 4 side square, right? Since we have to find out the altitude, I am equating both of them. So this is half base into altitude and it is already calculated area of triangle. Okay, so it is 2 and 2 is cancelled, A square. So OH is equal to root 3 by 2A, right? OH is equal to root 3 by root 2A, or we can say root 3 by 2A. Now OH and OF, both of them will be same because this diagonals bisect each other. So this is the midpoint of HF diagonal. So OF will also be of root 3 by 2A. OF is root 3 by 2A. Now for this square, DB is equal to root 2A, that is the diagonal of this square. So this is half the diagonal OB. So it will be root 2A by 2, or we can say A by root 2. Now we know the length OB, we know the length OF, right? OB is equal to A by root 2 and OF is root 3 by 2A. Now since diagonal makes angle 45 degree with the side, so this angle is 45, this angle is 45. Similarly in this square, this angle is 45, this angle is 45. That means, and angle O is common. So in triangle OAB and OEF, triangle OAB is similar to triangle OEF. Now if the two triangles are similar, their sides will be in proportion, or we can apply the Thales theorem, right? So sides will be in proportion. So AB and EF, AB by EF is equal to OB by OF. and OB we know A by root 2, and OF is root 3 by root 2A. So this is cancelled, root 2 is cancelled, so it is 1 by root 3. Okay, so what is AB by EF? That is 1 by root 3. So that was an interesting problem. I hope you are clear. If not clear for the first time, just watch the explanation once again. Bit time consuming, maybe a minute or some 1.5 minutes, but not at all difficult. Now in this figure, in this question, AB is parallel to DC, angle DAB is equal to angle DBC. Which of the following is true? Okay, so as we see the relationship, similar triangle concept comes up in my mind. Let's see what happens. Now this line is parallel to this line, that means this angle will be equal to this angle. Okay, and this angle is already equal to this angle, so it is A similarity. That means triangle ABD is similar to triangle DBC. I'm not writing down the sides in ratio, so do not get confused. Triangle ABD is similar to triangle BDC. Now if the triangles are similar, I have to take the sides in proportion, right? So in this triangle, this the side opposite to this angle is BD, and side opposite to this angle is DC, is equal to side opposite to this angle, it is AD, and here side opposite to this angle, it is BC. Now BD AD, the third one remaining is AB, and here it is DC BC, the remaining one is AB. I'm sorry, DB. Now just check, AB by BD is equal to BD by DC. So AB by BD is equal to BD by DC. So that's correct. Then AB by BD is equal to AD by BC. That's also correct. And AD by BD is equal to BD by CD. AD by BD, AD by BD is equal to in fact no need to check, we don't have any other option that says 1, 2 and 3, all of them are correct, right? So since 1 and 2 already are correct, so we just can drop the third one. Our answer is this, right? So a concept of similar triangle we have used over here. Now this question, in the figure ABCD is a trapezium, find its area. Okay, the non-parallel sides are having equal length, that means it is an isosceles trapezium. Now what we can do is, I just draw a line like this, then one more. This is nothing but the perpendicular or altitude of the trapezium. Now from this point, this is right angle, so from this point to this point the length will be 6 centimeter. So the total length is 12, and this portion from here to here, if it is 6, the remaining 6 will be distributed equally among this and this, being symmetric figure. So this has to be 3 and this will also be 3. Now we have 3, 5 and this is a right angle triangle. So if this is 3, this is 5, then it has to be 4. That means the altitude of this trapezium is 4. Now what is the area formula for trapezium? That is half into altitude into sum of parallel sides. So sum of parallel sides, that is 6 plus 12, 18. So it is 36. Okay, I hope you are clear. Now in the figure, the area of ABCD is ABCD, it is a quadrilateral, and the best part is there are two right angles. So what I can do to make it the problem very simple, I join BD. Now area of this quadrilateral will be nothing but the area of triangle ABD and area of triangle BC. That is sum of the areas of two triangles. Okay, now this is 6, this is 8, That means the third length BD must be 10. Being BCD a right angle triangle, this is perpendicular, this is base, BD is hypotenuse. So we have 6, 8, 10 Pythagorean triplets. So BD is 10. First thing, area of triangle BCD will be half base into altitude. So half 6 into 8, that is 48, so it is 24. So area of triangle BCD we have already got, that is 24. Now BD is 10, so BD square will be 100. So AD square will be BD square minus AB square, that is 100 minus 16, I can say 84. So AD will be 4 into 21, so it is 2 root 21. Okay, so AD is 2 root 21. So area of triangle ABD is half into 4, that is base into altitude. So it is 4 root 21. So 24 we have already got. Now it is 4 root 21. So this is the correct answer. Okay. So friends, good number of problems we have done in this session. In the next session we'll be taking more problems. Bye bye.